Hello guys, welcome to Robotic Electronics YouTube channel. In this video, we will be learning about PWM known as Pulse Width Modulation. It is very important to know about this, and many of the applications in the present are using this Pulse Width Modulation to vary the input voltage based on the control signal. So let us move on to the topic. Yeah, here you can see the width of the pulse can be modulated based on the need to control the brightness of the bulb and the speed of the motor. This is known as modulating the width of the pulse, that is PWM. Inverters, converters, SMPS, speed control circuits. One thing common in all these circuits is that it contains many electronic switches inside. These switches are nothing but devices like MOSFET, track, etc. In order to control such power electronic switches, we commonly use something called PWM signals. Apart from these PWM signals, are also used for driving the servo motors, controlling the brightness of the bulb, and even for controlling the speed of the processor fan inside your computers or laptops. The principle of PWM is used in many applications. If we consider this, the circuit on this bulb, you can look at this circuit. That this circuit can be used like it contains a switch and a battery and a bulb. So with these three, a circuit is made. We can control the brightness of this bulb based on the switching of this switch. Like when the switch is closed, here when you come to the circuit diagram, based on the closing and opening of the switch, the brightness of the bulb can be controlled. Here we can say that this is known as one complete cycle, like one complete period. In a complete period, 50% of the time switch is on and the rest 50% of the time switch is off. Like we are giving the voltage at 50% of time and voltage as low at 50% of the time. In this way, PWM, like we can modulate the pulse and you can control the brightness of the bulb, similarly the speed of the motor and much more. See, here you can look about the explanation in brief. Let us consider this circuit. Here the switching can be done on and off. For every 2 seconds, which is considered as a single period, the switch is on for 2 seconds and off for 2 seconds. Like 4 seconds is a complete period of time. Out of that 50% is on and 50% is off. Like this bulb will be on for 50% of time and off for 50% of time. In that way we can control the switching of this bulb. Actually the switch which can be used in the real time is the MOSFET and track and some. So in this way we can control the width of the pulse and modulate accordingly. So some of the important terminologies in the signal. The time in which the voltage is high, that is in which the switch is turned on, is known as on time, and the time in which the switch is turned off is the off time. Based on the on time, the duty cycle can be determined. This is the concept of duty cycle. See, if at all we consider the voltage VCC, that is the peak voltage as 5 volt, 0 to 5 volts. For the 50% of time in a period, it is 50% is on, that is 5 volts, and 50% is off, that is 0 volts. So this is 50% duty cycle. This pulse is having 50% duty cycle. It means that it is on in the 50% of the time and off in the rest of time. So it gives an average voltage of 2.5 volts. Similarly, 75% duty cycle wave will produce 3.7 volts as the average output voltage. In the same way, 25% duty cycle will produce 1.25 volts as the output voltage. Another important factor in determining the width of the wave is frequency. Frequency of the control signal can control the width of the pulse. Lower the frequency, switching will be the faster. For example, if we consider a high frequency duty cycle, if the frequency is more, then the for example here the frequency is high, it means that the time period will be low because frequency is inversely proportional to the time period, so it will be low. For the lower frequency duty cycle, the resulting signal will be in this way. For higher frequency, the resulting will be in this way. See, for considering the higher frequency signal, the switching will be the faster, like the switch will be turned on and turned off at a faster rate. For the lower frequency duty cycle, the switching will be in the slow way, like it will be turned off and turned on. For example, if you are switching, like if you are controlling the brightness of the bulb or the speed of the let us consider brightness of the bulb in the with the low frequency wave, we can observe that the brightness, like the bulb, is turning on and off with some span of time that can be caught by the human eye. Whereas in the high frequency duty cycle, we cannot capture the on and off time so that we can feel the dimness of the bulb and the brightness of the bulb. In this way, the frequency of the control signal always matters. Next is the how can we, if not the PWM signal, how can we manage the controlling of speed of the motor and brightness of the bulbs in the real time. Generally, a resistance can be used in series to the motor, that is a variable resistant, can be known as a rheostat. This can be used based on the switching of the resistance, the motor speed can be controlled. This is the traditional manner of controlling the speed of the motor and the brightness of the bulb. But in general, at present these methods are not being used, and many of the applications are switched to usage of PWM signal because of its efficiency and better way. How can we produce a modulated pulse signal? By considering a comparator circuit, to the positive side we'll be giving a sawtooth wave, to the negative side we'll be giving a modulating signal. Based on the sawtooth modulating signal, the modulated pulse signal can be produced at the output. Let us look in brief how to produce this modulated pulse signal. See, this is something quite interesting explanation about modulation. The input waveform is the sawtooth waveform. This is given as positive to the comparator. So the control signal. Let us take control signal VDC1 and another control signal VDC2. If the control signal is at this point, so the width of the pulse is very much red, like this blue color one is the width of the pulse. If the control signal is high, the width of the pulse, like the on time is in this area, so on time matters. So if the width of, like if the control signal is low, so the width of the pulse will be more, so the on time will be more, so more span of time on time. When the width is low, the on time will be less. Similarly, here when the width is more, the on time will be more. Based on the two control signals VDC1 and VDC2, we can expect the output pulsated wave signal. In this way, we can modulate the output pulsated signal based on the input sawtooth and the control signal. Finally, PWM, pulse width modulation, is an essential feature for connecting microcontrollers to motor or lights, providing a way to approximate analog voltage levels with digital signals. And using of PWM, you can control and program the brightness of the lights and the speed of the motors. That brings the real life to your projects. So finally, one thing we can conclude and end the topic is that based on the PWM signal, many of the applications are working efficiently. So this PWM signal is one of important concept before looking on to the working of with that concepts like controlling concepts related to the analog signals, how to control the brightness of the LEDs and the speed of the motors with the PWM signals is considered to be an important concept. So with this, we end the topic for today. So thank you. Please subscribe to our channel and like our video. Thank you.